Right, we learned what is QoS, we learned what are all various type of markings that we have, we learned different queuing methods in which we come across the priority queuing and class-based weighted fair queuing. Now, in in production today, we have combination of this both class-based weighted fair queue and priority queue. This is what called as LLQ. LLQ, see the word LLQ, low latency queuing. So when you follow this queuing method, you will not have much delay. You will have low latency. Low latency. Now, I told you this is a combination of two different queuing methods. The first one is PQ. PQ means priority queue. Priority queue is a queue which will be always active. Whereas class-based weighted fair queue is depending on the weightage, the queue will become active. I repeat, I repeat, I repeat. You see here, you got a lot of queues. Q1, Q2, Q3, Q4. The Q1 I have given to PQ. The Q1 is priority queue. And the rest of the three, I make it as class-based weighted fair queue. Now, what do you understand from this picture? This picture is very, very, very self-explanatory. But for the first time, I would like to explain this with pen. You see here, this particular queue is separate, whereas these three queues separate. What does this round explains you? It explains the round robin, meaning the traffic that enters this queue will always take the exit and it is always prioritized. The, the traffic in this queue will never be stopped or delayed, but the traffic in these queues need to go in round robin, meaning first finish this traffic. And when it is over, when all the traffic in this over, in this queue over, then the traffic in this queue, and then the in this queue, and then again go to the yellow, finish all yellow, and this violet, and this green. It goes in round robin. These three queues will never be active at the same time, will not be active at the same time. These three queues are in one after the other, whereas this queue will be always going, never stop. But this one, after 20% of traffic going, it will stop and then it will allow this queue 20%, and then it will allow this queue 10%. Again, it will go to 20% of this queue, and then 20% of this queue, 10% of this queue. It goes in round robin. So all that traffic that are inside queue 2, 3, and 4 will be going in round robin. Whenever it gets opportunity, it will go. Whereas the traffic placed in this queue are always served first. Always served first. And 50% of this physical interface bandwidth is reserved only for this Q1. This is what called as low latency queuing. Now, how do we do this? Did you understand what is low latency queuing? You understood, no? Fully? Do you have any question that is the meaning of it? Okay, if you don't have a question, then I can take you to the configuration side. See, here is the demo. Um, there are three routers, and between router 2 and router 3, you got some QoS policy, right? Okay, this is basic configuration. I want you to do this lab. That's why all the configurations I have put here. You know, even an IP address configuration. You understand? Router 1 basic configuration, router 2's basic configuration, and router 3's basic configuration. All right. Next, this is the scenario. First, we need a class map to classify the traffic that you want to put in priority queue. What is priority queue? The queue that will never stop forwarding packet, isn't it? The top queue. So we are planning to put all the voice traffic that are marked with EF. Yeah. So if a traffic is already marked with EF, I long back I taught you how to mark with EF. You know, IP precedence 7 or something we mark, and stuff that you need to now mark with EF. So you will go to router 1 and match the voice traffic and mark with EF and send to this router. Now this router will match all the traffic that is already marked with EF. All right, and then you write another class map for called signaling for with the marking of CS3. All right, that's another classification. And then you go to the policy map, call the class for voice, and set the priority. All right, so go down. The priority you are setting is 2000 kilobits per second. That is 20 meg. You're setting 20 meg bandwidth. Priority. It's a priority queue, so you don't use the keyword bandwidth. Use the keyword priority queue. It will create a queue of 2000 kilobits per second. All right, that is over. Next, you are still inside the policy map. You call the class map called signaling, and you reserve bandwidth of 1000 kilobits. And then you go under the physical interface, apply this outbound. That's all. How easy it is. Now, after you do, you verify whatever I have shown here. You do and see, you show, you open and you check in your configuration all this. All right. You also check by pinging. See, you need to ping using this TOS type of service 98 140. That's for voice and signal. That's where you are matching on the top. 184 is voice, 96 is signaling. All right, that's all. I have created a nice document for you. All that you need to do is just take any iOS will support this. Take three routers, and I have given you the basic configuration. Put the configuration, and then configure this, and then verify this. This is already done by me, but I did not do LLQ. I simply did a class-based weighted circuit for ICMP traffic on the other day. This time you are doing priority plus bandwidth, means low latency queuing. All right. Can you do this?